So now we can say about the NdOg laser. This is the one of the type of the laser, that is neodymium, yttrium, aluminium garnet. This is shortly called as a NdOg laser. So the NdOg laser is a doped insulated laser. It is a 4-level system in which the active medium is taken in the form of a crystal. Here the crystal is doped during its growth. So this type of laser has number of energy levels with same energy. This laser is used to generate high power intensity. So now we can come to the characteristic of NdOg laser. It is a solid state laser. It is a solid state doped insulator laser. So its active medium is yttrium aluminium garnet. Its active center is neodymium ions. Its pumping method is optical pumping. Its pumping source is xenon flash lamp. It have optical resonators, that is the two polished polished with silver, and ends of the rods are polished with silver, and two mirrors. One of them is totally reflecting and the other is partially reflecting. Its power output is 20 kilowatts and its nature of output is pulsed wavelength. Its wavelength is 1.064 micrometer. It is a characteristic of NdOg laser. Now we can come to the point of principle of this one. The term doped insulated laser refers to the active medium, that is yttrium aluminium garnet doped with neodymium Nd3 plus ions. The neodymium ion has many energy levels. Due to its optical pumping, these ions are raised to excited levels from ground levels. During the transition from metastable state to E1 state, the laser beam wavelength 1.064 micrometer is emitted. The figure shows the four level of laser. In the beginning itself we told it is a 4-level laser system. So there is a 4 levels are there, that is E1, E2, E3, E4. 4 levels are there. Now come to the construction. The active medium is made as a rod which has yttrium aluminium garnet, that is Y3AlF5O12, that is yttrium aluminium garnet doped with a rare earth metal ion, that is neodymium Nd3 plus. The neodymium ion normally occupies the yttrium ion and provides the energy level for both the lasing transition and pumping. This rod is placed inside a highly reflecting elliptical cavity. The figure shows that one, how where is the reflective mirror is placed. One is a fully reflecting mirror, that is in the left side, and another one is a partially reflecting mirror, that is the light's right side. There's a laser radiation, that is output of laser is coming out from partially reflecting mirror only. There is a flash tube is there. Okay, now come to the next point. The closed optical coupling is made by placing the xenon flash lamp nearby the laser rod. In such a way, the most of the radiation from the flash tube passes through the laser rod due to its elliptical cavity. The flash tube may be switched on and controlled with the help of a capacitor. The discharge of capacitor is initiated using a high voltage source. The optical resonator is formed by grinding the ends of the rods and coated with silver accompanied by two mirrors. One is 100% reflecting and the another one is a partially reflecting, with this included to increasing the efficiency of the output beam. Next, the working point. The xenon flash lamp is switched on and the light is allowed to fall on the laser rod. The intense white light excites the neodymium ions from the ground states to various energy levels above E2, not E2, more than E2. Hence, the atoms are raised to the group of higher energy levels E3. E3. See the E3 energy levels? From the it is a temporary one. So all the neodymium ions can sitting on the E3 for a certain time. That is a metastable state. It is not a metal stable state. It is a state which can occupy by the neodymium ions. From this E3 state, everything can be coming out to the lower energy levels. There are the two lower energy levels. One is E4 and another one is E2. E2. So from E3 to E4, all the atoms can coming by emitting a non-radiative decays. So now E4 can be called as a metastable state. From E4 to E3, the excited energy atoms can give its excess energy as a laser wavelength, laser light, and coming to the E2 state. From E2 to E0, that is a ground state, it emits its excess of energy. It is not as a laser, it is becoming as a non-radiative decay. So from this energy levels, the ions make non-radiative decay and is gathered in a state is called as a metastable state until the population inversion is achieved. So the population inversion is achieved, the stimulated emission build up rapidly. Hence, the pulsed form of laser beam of wavelength 1.064 micrometer is emitted during the transition from E4 to E1. A large amount of heat is produced by the flash tube during the working. Hence, cooling arrangement is made either by blowing or circulating water over the crystal. So, now come to the points of application of Indiog laser. It is used in transmitting signals to a longer distance. Figure shows. Next point is it is used in long haul communication system. Then the next one is it is used in endoscopic application, and the final one is it is plays a vital role in remote sensing applications. Thank you.